Welcome back to the Maker's Vault. In today's episode, we're going to be talking about all things rotary transfer technology. So whether you have a rotary transfer machine, a Hydromat in your shop, you're interested in the technology, or you're just interested in machinery technology in general, this episode's for you. And lucky for you, I have the Hydromat expert, Willie Eichele, with me today. Dad, you ready to talk about Hydromat?
I'm ready to talk about Hydromat.
I always joke with people that if the Cleveland Browns was not my first word, Hydromat was probably my first.
Probably a close second.
At least it was your definitely.
Hydromat has been a big part of our company since we started it and continues to be today, and I certainly have a passion for it. As you know, I did my apprenticeship program at Hydromat when I started my career, and fantastic technology and even better people. So yeah, it's a big part of what we do.
Big part. Well, before we get into the episode, please make sure you like this video and subscribe to the channel to continue to support our Maker's Vault series. So without further ado, let's start at the beginning. Grandpa, 40 years ago, decided to partner with Hydromat.
Yep.
Why did he make that decision? What did the industry look like at that time? Why was Hydromat a good fit? Can you talk about some of those things?
Yeah, well, I think timing is everything, and I'm actually in the middle of a book now called Blue Oceans, and I think this is like a perfect example of a blue ocean opportunity that Hydromat had back then. So the market in the U.S. was there. There was a lot of people making high-volume screw machine parts, and they were doing it one of two ways. They either had a machine or a simple part to where they could drop it off complete on a screw machine, which is a high volume multiple spindle screw machine, or they were doing a secondary operation, or sometimes three operations to complete the part. Wow. So they would drop the part off on a screw machine, then they would take it to a backside drilling machine, and then they'd take it to a tapper to finish the part. So three different operations, overlapping them, getting them a higher throughput because it wasn't all being done on one machine.
Sure.
But that was the marketplace, and Bruno Schmitter and Peter Fry came over, established themselves in St. Louis with the rotary transfer machine. So that solved that problem. That was the blue ocean opportunity that Hydromat can take the part and make it complete on one machine faster than those three could do it, and with no operator, and with more quality. So It was just the market existed, but people were doing it a different way, and Hydromat came in and just flourished like you couldn't even imagine through the late 70s, all the 80s, and the 90s.
Wow, that's pretty cool.
Yeah.
And that they've stayed up with the technology, which we'll get into that a little bit later.
They've like any good business, they've evolved into something different today, but to accommodate or complement them with today's technology. But
So I want to start really elementary as well, because some people, I know even at PMTS this year, we had a force unit, and they're like, what the heck is this? Some people are just not familiar with rotary transfer technology. I know it's niche. So can you explain it the best you can? Maybe we can throw up some B-roll too.
Yeah, I think that the easiest way to think about a rotary transfer machine is like an assembly line. Why do people have assembly lines? To get more throughput, right? So they might have a guy putting these two pieces together. This guy is putting a plastic component on it. This guy is bolting it to the subassembly, and this guy's doing something else. So at the end, all their activities are overlapped, so they get a higher throughput. A Hydromat machining center is no different, and it's a machining center. So you have either 12 or you have 16 positions around a table, and everything happens at one time. So if you feed in at station 1, if you load a blank or bar feed into station 1, you cut it off. Now you can drill at 2, tap at 3, turn at 4, do whatever, roll mark at 5, turn it around at 6, and machine all the backside features. That's how the Hydromat be over and beyond like a screw machine, because it's got as much back working capability as front working that you finish the part. So basically, if you can imagine all 12 stations firing at one time, coming out and indexing the table, that's your cycle time.
Okay.
So the individual part that's going around would have your cutoff time, your tap time, your all these features you would add. If you just followed that one part around, it might have 60 seconds of machining time to it. But once the table's full, every time it indexes, one falls out.
Right. Okay.
So it's your longest operation plus your table index time. So it's very common to have, 3-second cycle times to 15-second cycle times. And that's normally what people look at a trade show. They're like, how in the world you make that in
that amount
10
of time.
seconds?
Yeah.
Well, you're not. That particular part you're holding had about a minute and a half of machining on it. But with a rotary transfer machine, you're overlapping everything and you're making it complete.
So really, you're just looking at your longest cycle time, which would be the part from when it comes in, whether it's bar fed or loaded in from a blank, and it gets around to drop off. But after that, you're looking at the time it takes to drop them individually once
You're
they get
looking
to the
at the
table.
longest machining station. So if your cutoff time was 5 seconds,
Okay.
and everything else, all your other operations were 4 seconds, your cycle time would be 5 seconds on that part because all
crazy.
the 4 seconds fall within
that 5. That makes sense. Okay, so yeah,
So-
once part 1 gets in, it goes to 2. Part 2 comes in, gets cut off. Now part 1 is at part 2, and then it just keeps going
Keeps
around, and you
moving
just
around.
dropping them.
Keeps moving around. And again, the beauty of it, for somebody that doesn't, have any experience with rotary transfer is, like I said, the back working operations.
Okay. Because you can turn it
the part.
around.
That's one of the stations. You're taking the part out of your fixture, turning it 180 degrees, put it back in, and you can finish it. That can be on a 12-station machine. We call that the inverting station.
Okay.
That could be at station 2, it could be at 8, could be at 9, could be at 12. A perfect Hydromat part, a part that screams Hydromat, is a part that's got the same amount of machining on the front side as the back side.
Okay.
So having that inverter in the middle means you got a pretty busy part. You got a lot of features on the front, a lot of features on the back. It really, if you have the volume component, it really is the only way to do it.
To do it. So what about, I know we have parts here, so I
Yep.
want to talk about some of these parts. So how did the technology come about? We kind of already answered that question.
Yep.
The industry coming over here, there was a need for it. There's a need to drop all these parts off complete if you have this type of cycle time. So let's talk about the part types so viewers can kind of get their eyes on what is a good Hydromat part. I know we said back work and the front side working, but can you talk about one of these parts and the way that it would be done?
Yeah, I think first of all, you with a rotary transfer machine, any rotary transfer machine, you're cutting it off first, and you're rotating tooling.
Okay.
So most people look at parts and they think, okay, on a lathe or on any CNC multi-spindle, you're rotating your material and you cut off last.
Right.
So that's the biggest thing to try to grapple with, and it's kind of funny again at trade shows when people come up on the platform and they're just looking at it going, how is that bar not spinning and you're finishing that part? So our tooling rotates.
Got it.
Turning
Got
with
it.
a rotating tool, your parts stay stationary. So a good Hydromat part is, again, I already said, a part that's got some balance to it. Not all the time, but it makes it a really no-brainer if it's got some balance on it from front to back. Because screw machine technology is very effective too, CNC multis, but you're limited on that back working side.
Okay.
On a Hydromat, you're not limited on the back working side. So if you took, this is, we don't have to get into the weeds of everything, but a good Hydromat, because you're not rotating the material, you have the ability to do, this is probably a better one, you have the ability to do a lot of off-center work, because
Okay.
your spindle can just come off-center. You have the ability, as I already said, to machine both sides of a part. So live features, like this part with the cross hole, or this part with these 3 off-center holes, or these 3 off-center holes on the backside, those are kind of ideal because they're very hard to complete within the cycle time that we can do on a
That we can do
Hydromat,
'em.
on a rotary, on any other type of medium volume or high volume machine. With that said, if the volumes are high enough, and I don't want to contradict myself later because I probably will talk about the
volumes,
flexibility
yeah.
these days, but if the volumes are high enough, you take a part like this, it has no off-center holes. It has no cross drilling or milling, but it has a very nice area to clamp in the middle of the part.
For
So-
for the front.
So you
thread,
can
the back,
feed it
yeah.
in, clamp it, cut it off. You can do this turning. You can do this drilling. You can do this threading. You could turn it around, clamp on that same hex material. You could do the turning. You can do the threading. You can do the drilling. You can do this face work. Everything on center, no live work. But, again, on a part like this, which is probably 7/8 hex or so in steel, it looks like, free machining steel, you're probably talking about, I don't know, the thread or maybe even the drill driving the cycle time. So if you're going to drill this and it's going to take 6 seconds, your threading's less than 6 seconds, your turning's less than 6 seconds, your cutoff's less than 6 seconds. Really easy clamping on front to back, finish the back side, and you can
bang.
make a part, like that in 6 to 8 seconds in steel. So, this is another one that, this is a brass part, but it has cross hole.
Yep.
Here, as you can see, it's got these milled flats. That starts to scream Hydromat. It's got threading on both sides.
Yep.
It's got a lot of ID work, ID thread on this side, and a lot of ID deep work on that side. That's not going to be an easy part to do on a CNC multi-spindle.
No. So I want to pause you though really quick because
Yep.
I know the audience is probably is thinking this. Does size of part, what are the limitations for size of parts on a Hydromat, or is there no limitations? The second question is, what is the capability within each spindle? Is it X, Y? Like, what is it? 2-axis, 3-axis spindles? Can you change can one be a 2-axis for it?
No, it's a good question, and it's our benefit and it's our curse on the Hydromat side. Hydromat is very modular.
Okay.
So when you're not rotating the material, it makes it and you just have a machining station. It allows you to do really anything that you could imagine doing in that work envelope. To your question, yes, you have single axis units for like drilling or turning, and then you'd have 2-axis units for profile turning, a dynamic head that moves in X and Z to profile turn an OD, or you put a boring bar to do an ID, and then you have 3-axis units, which you could use for thread milling. It's like a little horizontal machining center. In that work envelope, you could do anything. All that off-center work you can do, stitch drilling, anything like that. You can do. So, yep.
So kind of one more question, maybe slightly on the technical side, but in terms of tooling, when I'm hearing this, and I'm not an engineer or product specialist or anything like that, but obviously your spindles are turning a lot during this time. What do customers do, or how do they handle the changing over of tools? Do they have to do it often? Is it frequent?
It depends on your material. It depends on your cutting tool. A machine like a Hydromat is not a machining center, so you don't have probing inside the machine or tool touch probing or anything like that. So on a machine like this, you rely on preset tooling. So say we're back to that 12-station machine. Station 3 has tool load monitoring on it. It senses it's getting dull. It tells the control shuts it down, tells the operator station 3 needs changed. He has a preset tool for station 3.
Oh, okay. Yeah.
Sitting in a station 3 cabinet back here. So he opens up the lid, he takes out that 3 holder, puts that one in. It's HSK quick change tooling, manual quick change tooling. You put it in, you hit start, and away you go.
Okay. So not pretty easy,
very easy. And I was thinking too, when I was thinking about the units, very important with the Hydromat design is it's a flange unit, a flange mounted unit. It's not a slide mounted unit, which allows us to bring the machine casting up, mount the units around, and then enclose it on the top, so nothing is exposed to chips and coolant besides your work holding, your cutting tool, and your part.
Okay.
So your critical electrical motors and valves and all that kind of jazz is all outside the machine, not exposed to all the
elements and the other things
inside the machine. So, and that's because of that flange flange mounted unit design and machine base.
That makes sense. And then I did ask this, but I know we didn't get to it. Part sizes, is there limitations there? Or?
Yeah, there's a limitation to everything. I mean, Hydromat specifically, a 12-station machine is a 1-inch bar machine.
Okay.
If you're feeding into collets, you can have chucks on the machine too if you're loading blanks, and you can get a little bit larger than that in certain directions. It really depends on the features on the part.
Okay.
So I don't want somebody to listen to this and say, oh, my part's a little over 1 inch, so I shouldn't talk about the 12-station. Everything can be expanded a little bit, but it's really, application specific. But in general, 1 inch, 25 millimeter for the 12-station.
Okay.
And an 1 3/4 45 millimeter for the 16 station.
Okay.
And these are horizontal Hydromat rotary transfer machines. We also have trunnion style machines.
Yep.
And what we have, what we call an HS machine, which is a indexing chuck machine. So the indexing chucks sit on like top of the table instead of collets around the periphery of the table.
It would be this way.
And those are all indexable. So if you have a prismatic part or a T or an elbow or parts that you might have talked about the inverting unit in one station, an HS, you can index that. You can reorientate that part in any of those stations. So you can do a part.
I don't think I've seen one
like
of
this.
those.
You know, you can hit this at one station, this. All you got to do is index the chuck. So
I don't think I've seen one of those. We could do a whole episode on all the different Hydromat machines. I think we could probably do that.
Yeah, I mean, it just really depends on the application, and there is nobody better than Hydromat. Not just because we saw they've crushed the industry in the States for 40 years. So I should plug that. I mean, they're a U.S. based company. They've been here for 40 plus years. They've got 2,500, 2,800 machines installed. They're not a U.S.
It's not a sales office.
Sales and service and parts center, which I would say every single one of our competitors, if it's a rotary transfer company or if it's a CNC multi-spindle company, nobody is building the machines here in the U.S. Maybe with the exception of like Davenport, but that's not a comparison. But that is huge. That is huge. So Hydromat, if the part fits within the envelope, let that engineering team dive into it and find a way to solve the problem. They're really, really good at it.
So if we're simplifying, the conversation in terms of the benefits of a Hydromat machine, what are the benefits?
Cycle time, speed, quality, labor savings.
Okay.
One big one that is always a part of existing customers' ROIs on machines, if they're moving something from a screw machine to a Hydromat, is material savings.
Okay.
We don't need to get into all that now, but our bar end length is a lot smaller. It's about a part length and a half on each bar that we waste. Other technologies have a much longer, so we're making more parts per bar.
Sure.
And oftentimes our cutoff saw is thinner than a parting tool on a screw machine at least, or a lathe or things like that. So you're saving material there, and the operating efficiency of the system. That's a really big one that I always harp on. Because we're not rotating the bar, it makes it a very simple process to load.
Just to load in.
It's fast.
Sure.
So where a bar rotating machine might take 20, 30, 40 seconds to change a bar, all we're doing is pushing the trailing edge of one bar with the leading edge of the next one, and at the very end go through a bar change, face off, and keep going. So 10 points higher in efficiency than a traditional screw machine. So efficiency, material savings, part quality, throughput, all that good stuff.
So we talked about the benefits of the machine. Now we know over time, we've heard over and over and over again, you've told me over and over again, a lot of people think you need really high volumes to have a Hydromat. That's changed. Can you talk about that? What has Hydromat done to make it a little bit, so you can apply it to more jobs than just the really high production jobs?
Well, everything we've talked about is the same from 40 years ago, besides the units are now all CNC controlled.
Okay.
So you no longer need, they used to be manually changed. Your RPMs were manually changed, your feed rates, your rapid approaches, everything was manually changed. You didn't have a 3-axis unit that was capable of doing a lot of different things.
Okay.
So today you got the same style machine, but with CNC, if it's configured right, it allows you to run a lot smaller batch sizes because you can change over a lot quicker.
Okay.
It was all manual before. What could have taken a day to a week is probably 1 hour to 4 hours today in terms of changeover.
That's a huge difference.
So if you can change over that quick, now you can run smaller batch sizes. So Hydromat has definitely evolved. There's no doubt there are still some high volume running jobs that come across our desk, but that changed. That changed a lot when a lot of that type of work went overseas. The simpler parts. So Hydromat evolved, and you wouldn't believe some of the types of parts that are being made in the different industries today that we couldn't even have approached in the firearm business, for example, years ago, because we did not have the CNC. It would have
The CNC, you couldn't have done the
too
jobs.
complicated.
Yeah.
No, leave it on a turn mill center, buy 7 or 8 of them, and make the product that way.
Yeah.
Now you can run 5,000 pieces.
I was gonna
Change
say-
over, run 3,000 pieces. Change over, run 10,000 pieces within a part family. Totally dissimilar parts, like this one to this one. Sure, you can. Somebody would run those. Good houses out there would run those in 10,000 piece runs, 8,000 piece runs, and then change over.
So that was going to be my next question. Actually, could you give some ranges for like the audience to kind of understand what we're talking about in terms of, smaller jobs for Hydromat versus larger? What would be considered those shorter run jobs in terms of pieces?
Yeah,
Typically, it's like a range.
I mean, again, we've got within a product group or a product family, we've got a lot of customers that'll run 500 pieces, 1,000 pieces, 3,000, 10,000, change over the machine 3 times a day.
Okay.
Granted, these are typically, an OEM environment where they can control their scheduling a little bit more than a job shop.
Okay.
So I don't want to mislead. That's not going to be probably very feasible or available to a secondary, a tier 2 or a tier 3 shop.
Sure.
Or a tier 1, 2, or 3 shop. But that's you can do it. The CNC has added a tremendous amount of capability to rotary transfer machining.
And let's say it's the right part, right process. What are the higher volume size, like higher volume ranges?
The higher the better, right? Because
Okay.
if there's nobody that's going to make the part faster, more efficient with the material savings.
Okay.
It's
And
just
that's
not, It's just not going to happen. So if you have a job that's 1 million pieces or 2 million pieces, you start doing the math. Right. I mean, you just how many machines do you need to make a 3 million piece run?
Yeah.
Or is it one machine because your cycle time's 2.5, 3.5 seconds? So, it just they both fit, but the higher volume stuff has become dedicated stuff, I should say.
Sure. Okay.
Has become less because of, like you see in everything in life, there's more variation in everything.
Mm-hmm.
So there's not like a lot of commonality with components. There's a lot of variation to everything, which means there's a lot of different SKUs, which means, the batch sizes become smaller, which means you've got to have CNC on a rotary transfer to keep up.
To make
But
it
there's
make
always
sense.
a threshold.
Yeah.
Sometimes it would be best to have 2 Mazak Syncrex machines. If you only need to, produce 150,000 pieces and you start doing the math, that makes sense. But if you start to need 4, 5, 6, 7, 8, 9, 10 Swiss machines or 10 fixed headstock CNC machines or something like that,
This is going to make more
floor
sense.
space, speed, labor, material savings. There's a threshold to everything, but when you tip over that threshold, it becomes a no-brainer.
So I like because my next question was going to be, generally speaking, what types of shops, if someone's listening to this and like, oh, wait, that is kind of me. I am doing that. Maybe I should look at Hydromat. What are kind of those key things that shops should be on the lookout for, whether it's in their shop that they're currently experiencing or a job that they're going to be getting soon or currently have, that they're looking for a piece of technology that they should, keep Hydromat in mind?
I think we get calls all the time from people that say they've got a great shop, they're an existing customer for standard CNC machines, and they get this part across their desk, and the customer's asking for 400,000 of them, and they just have no ability to do that.
To do it.
It would make no sense in the world to make the part in 40 seconds or 80 seconds or 120 seconds. You'd need a whole building extension to put the number of machines on it, let alone trying to find people to operate. All the issues that go around that. So, if you're a shop that happens to see a higher running job that you can't do on your current, make cost effectively on your current type of equipment, that's when you should call your Hydromat. Call Hydromat Direct or call your Hydromat dealer and get engaged. On the Hydromat side, the sales group, if it's direct or outside, it's not I need your order today type thing. Sometimes customers get a little intimidated with that. That's a different type of machine, and we sell those too. But with Hydromat, it's a consulting thing. It oftentimes takes a year of education, a year and a half of education. I can tell stories, 15 years of education before somebody finally
makes
stars
the decision.
align, they get the job, they go out and get the machine, and then they make babies after that. It's easier after that, but I mean, it's a consulting thing, so don't ever hesitate. Just reach out and let us take a look at it. If it doesn't make sense, we'll be the first one to say.
Yeah.
If it makes sense and you need educated, we're going to take the time to educate you.
What are some signs for, so those would be like if a high volume job came across your desk, but what about it small batch runs? What would be kind of some things customers should be looking at where a Hydromat may make sense for the small batch?
Families of parts.
Okay.
Families of parts like we talked about. I mean, you're not going to buy a Hydromat for $1.5 million to make 100,000 pieces that have a cycle time of 7 seconds, right? It doesn't make any sense. Anybody can do that math. But what you should do at that point in time and say, how much can I utilize that machine or that investment based on that one job? Mm-hmm. What else am I running?
What else can I put on this machine? Where can I go in the
shop and say, well, this is the same material, but it's a different type of part? Well, I mean, I can't tell you how many machines that we've sold over the years that's exactly how they justify the machine. Well, I got this anchor job that's whatever it is, 250,000 pieces, but I've got these other 5 jobs I run. We do a couple 100,000 of each one of those.
Wow.
Now we put together a changeover matrix. We configure the machine for all those types of parts, and the customer can benefit. Let me tell you, there is no better, more cost-effective way to make a Hydromat part. In the industry, and this is kind of funny, but in the industry, we get buyers that call sometimes that say, we're looking for somebody. Do you have a customer that might have Hydromat pricing? They don't even know what it means. They don't even know what it means. Hydromat pricing is associated with the most cost-effective way to make parts.
You're kidding.
Buyers that don't even know what.
They just say that because they know
it's Hydromat pricing. They don't know what that exactly means, but it's Hydromat pricing. Because if you make things fast,
oh my gosh,
your piece price is low. So that's something to be said for customers out there that that's what a lot of buyers that are outsourcing these types of jobs are looking for is somebody with
Hydromat pricing.
Hydromat pricing. There's only way to get that. There's only one way to get that.
That's incredible.
I shouldn't say that.
That's
there's
funny.
Other ways to get Hydromat pricing. I don't want to be arrogant, but there's other rotary transfer companies that can, I guess, get the same cycle time. Not the same organization.
Not the same thing. Quickly, though, we could touch on that. I know we're kind of running out of time here, but in terms of perception, I mean, you've always said it. The biggest competitor to Hydromat is the perception of the machine, the technology, the volumes, etc. Outside of that, is there actually any other competitors that are in the space that are going to be competing with something like this?
Of course, yeah. We've got a handful of competitors over in Europe. Like I said, they all build fantastic machines. They have parts and service centers here in the U.S. They're not building the machines here in the U.S. And what does that mean? I mean, that's a statement, but it means a lot because that builds an expertise and internally to Hydromat that's second to none. They're not just setting up machines and running them off. They're building them and rebuilding them and doing the control upgrades and designing fixturing. They're doing all that in-house. So.
And they're making those decisions in-house. They don't have to call an office
that's a good point, and maybe you've heard me say that before. I have been, whatever it's been, 35 years, I've never heard once I have to wait on Europe for an answer for anything.
Now,
we've sold a fair share of other brands out there, very good brands. I heard it a lot. The decision making or the U.S. president, his stick is only big enough.
Right.
Otherwise he's got to go to the motherland to get approvals and what can be done here and there.
Doesn't exist in Hydromat.
There's a few guys in St. Louis that make decisions in about 2 minutes, and they're made. So the customer benefits from that.
That's awesome. So I know you touched on rebuilds really quick. I just want to touch on that really quick. Hydromat obviously is their technology, their platform, what they're doing is all still the same, but they've come a long way in terms of adapting to what the industry needs. But what are we doing still to service and support the legacy customers that don't have the CNC units?
That's years ago. I think it was 2017. We established a joint venture with Hydromat for that exact reason. And where we draw the line there, and that's called Hydromat Re.
Yes.
That's our business that we run out of here, and we have a division of Hydromat Re in St. Louis as well, outside of Hydromat in O'Fallon. So what Hydromat has evolved into is focusing on those CNC machines and systems and solutions. upgrading machines, rebuilding machines where there's a lot of CNC added to the machines. Where Hydromat refocuses, and we never can abandon our legacy customers,
No.
which is part of the reason we decided, hey, we can't do all this out of St. Louis anymore, and we'll move it into this new business. Is the Hydromat Re side of things. So when they're legacy machines with no CNC on them, we take them in here. I think we got over 20 of them in inventory right now of HS machines that you said you haven't seen, HBs, the 2512s, the Trunnions, and we keep them in inventory and rebuild them and repurpose them for those high running jobs that some customers still have at a fraction of the price, but at a fraction of the flexibility as well.
Okay.
Right, but yeah, we do that. So we've got an answer for the more complex rebuilds and upgrades. They go to St. Louis. The simpler ones with no CNC come to Hydromat Re, one of the two facilities. So we've got it covered.
And just to be clear, there on the Hydromat Re side, you said we have inventory, but we also, if a customer calls and says they need a rebuild, we don't just rebuild our inventory.
No.
We'll rebuild a customer. I just want to make sure.
No, it's
we
about
have
half
that
and half.
clear.
The customer would call and ship us their machine. We'll rebuild it, reconfigure it to
Yeah.
whatever degree they want it to be done, and then ship it back to them. Run it off or not run it off. So yep.
Awesome. Well, I think we nailed it all on the Hydromat
I
stuff.
think so. If anybody has any opportunities or anybody that's thinking about just wanting to get more educated on Hydromat, please reach out to Hydromat in St. Louis, or if reach out to me and we'll get you connected to the right people.
Yeah, feel free to leave a comment as well if you have any questions. We could pass them on to the right people and answer them back to you guys. Well, thank you so much for watching. Again, don't forget to like and subscribe to the channel to support the Maker's Vault series. We'll see you next time.